All right, we have a vector field here, and we're going to answer the question first, is this vector field conservative? And this is a straightforward calculation involving derivatives to find out if it's conservative. We look at the x derivative of the second component, that is 2x, and we look at the y derivative of the first component. The y derivative of the first component is also 2x. Those are equal, so yes, this vector field is conservative. So since it's conservative, we're going to be interested in the potential function for it. So the next part or follow-up to this question would be find phi, the potential function. So how do we find the potential function? Actually, let's use v. V is how physicists will do it, so let's use v for the potential function. We know that v sub x is our first component here, 3 plus 2xy. And we know that v sub y is the other component, x squared minus 3y squared. And those are derivatives, right? The x and y derivatives. So we're just taking antiderivatives to get back to v itself. So the antiderivative here, we're taking an antiderivative with respect to x. So v is 3x plus x squared y. And then remember, when we do an antiderivative, we have a constant. So I'd have plus c here. But I've got two variables, and so the constant would just be a constant in x, meaning this could be a function of y. So instead of just a general constant, when I'm doing an antiderivative with respect to x, I get a general function of y, some general f of y here. You can always check. Take the x derivative of this. The x derivative is 3 plus 2xy plus 0, so 3 plus 2xy, and it works. We got back to the partial derivative that we were given. Similar for the second one, v, I'm taking a y derivative now, so I have yx squared minus y cubed over 3, and the 3's cancel, and then plus some constant, which is a constant in y only, so some function of x, so plus a g of x. Once I have this, I'm just looking for the common terms. The potential function, we have a 3x, and we have a minus y cubed. There's also an x squared y. That's the potential function, and it works. We can check it. You take the derivative with respect to x, and you get what you needed. Derivative with respect to y, and you get what you needed. It turns out that this general function of y here was the y cubed, and this function of x here was the 3x. And then the other function was overlapping. And there will always be some overlapping bits that we put in, and then some functions of only the x or y. Or there usually will be anyway. So there it is. There's our potential function.